Hi, everybody. Welcome to episode 3 of Climate It's a Hot Topic. And in this episode, I would like to talk about what is potentially a somewhat terrifying triple greenhouse gas cocktail doom cycle. So let's talk about that in today's episode. Now, if you've watched either of the last two episodes, you will know that just last year, we emitted 36.3 metric gigatons of carbon dioxide, CO2. That means 36.3 billion metric tons of CO2. And when you consider that each metric ton weighs over 2,200 pounds, just last year, all of humankind emitted more than 80 trillion pounds of CO2 just last year. That's unnatural human emissions from our global economic activities related to our use and burning of fossil fuels. We have taken a system that was in an effective but delicate balance, a balance that was ideal for plant and animal life, and we have basically thrown that system off by putting all of the CO2 into our atmosphere and our oceans each and every year. And when you remember that the carbon dioxide element is quite stable, it stays in the atmosphere for 300 to 1,000 years naturally, you can see how it can build up when you're putting that amount into the atmosphere regularly. But wait, there's more. Earlier this year, we hit 421 parts per million of CO2 in our atmosphere. That is a 50% increase since the start of the Industrial Revolution in the late 1700s. But it's also a 50% increase over our baseline average levels of CO2 for the last 10,000 years. And what it's led to right now, 1.1 degree Celsius, almost 2 degrees Fahrenheit rise in global temperature since 1880. That doesn't sound like much, but take a look at this. It's not just CO2. We've gone crazy with adding it to our atmosphere through the burning of our fossil fuels, and we're seeing really hard evidence of this with our higher average temps, our rising sea levels, and our more volatile and extreme weather events. That includes massive increases in ice melt, among many other signs. But CO2 doesn't act alone. It has some helpers when it comes to global temperature rise. There are other greenhouse gases, most notably water vapor and methane, which you know is natural gas. And the more CO2 we keep putting into the atmosphere, the higher amount of both water vapor and methane we can also expect in the atmosphere. Now check out this graphic I got from the NASA website. You're probably most familiar with water vapor when you hear the phrases total humidity and relative humidity, which are basically just a reading of the amount of water vapor in your local atmosphere. A recent IPCC report found that water vapor is now increasing at 1 to 2% per decade. So that means globally we're increasing humidity and water vapor amounts in our atmosphere. And water vapor acts like a blanket. It holds in the heat, it doesn't let it escape back out into space. So when you increase CO2 and increase temperature, you also inherently increase water vapor. And you know it, when it's more humid, it feels even warmer than the actual air temperature because of the fact that the air can hold in more relevant heat. So carbon dioxide and water vapor work together, basically creating a positive feedback loop that will continue the rise of temperatures. But here's where it gets really scary. If you take a look at the graph below, Arctic temperatures have actually warmed almost 4 times as fast as the rest of the planet's temperatures since 1979. Now you might be thinking, hey, that's cool. We can now send ships through the Arctic Ocean. We can drill for oil and gas in the far north. There's a longer fishing and crab season in the Bering Sea. Yeah, wait a minute. We need to talk about this other greenhouse gas now called methane. In the last episode, you may remember how we discussed that both dead plant and animal matter can get locked up as carbon underground. That's how fossil fuels are created, through the compression and locking up of that carbon over deep time. But there's another way it gets locked up. Up in the Arctic, much of that carbon gets locked up in the permafrost. Now think about the name permafrost. It was supposed to mean permanently frozen, or at least when we discovered it, we thought it would stay that way. And as long as it stays frozen, it keeps the carbon locked up. But once the permafrost melts, it can actually release huge amounts of greenhouse gases, especially methane. Methane naturally occurs from the breakdown of dead plant and animal matter, but if it's frozen up, it's effectively locked up. The US EPA estimates that methane is 25 times more potent as a greenhouse gas than carbon dioxide, although I read an article from Stanford that said it might be as much as 80 times more potent. Luckily, it also breaks down much faster than the 300 to 1,000 years that it takes for CO2 to break down. But if a huge amount of methane were released very quickly, that could really change things. And wait, hold on. There's yet one more massive store of locked up methane on planet Earth. Do you know about the methane hydrates? I found this graphic right here on the Western Oregon University website. There are massive amounts of these methane hydrates surrounding all of the major continents, as well as in the Bering Sea and the Arctic Ocean. They are basically layers of intensively compressed methane held at the mid-levels of the ocean, and it's the combination of both water pressure at depth and water temperature. So it's a combination of pressure and cold temperature that keeps it basically locked up. But if those temperatures in the mid-column of the oceans increase, that methane can and does get released into the atmosphere. The hydrates break down, the methane gets released up through the ocean water column. And you got to remember something, it's not just melting permafrost and methane hydrates. We also are releasing methane every single time we drill for oil or gas or mine for coal. You got to remember that we release that methane often in the form of leaks at every single step of the mining, drilling, production, and storage process. We also release a huge amount of methane from our commercial livestock operations around the globe, as well as from all of our growing landfills around the planet. Our human actions are releasing methane at increasing amounts, just like we are with carbon dioxide. So let's just put this all together. We've increased CO2, which is up 50% from the late 1700s, which has increased global temperature. That increases the amount of water vapor in the atmosphere, which is now increasing 1 to 2% per decade. That helps raise temperatures in the Arctic at an even faster rate, 4 times the global average, which greatly increases both the melting of the permafrost and the warming of the oceans, not just the northern oceans, pretty much all oceans, leading to rapidly increasing releases of methane from both the permafrost and the undersea methane hydrates. And take a look at this chart that I got from an article I found out on CNN. But it's actually an analysis of atmospheric methane levels from the Noaa Global Monitoring Laboratory since the early 1980s. We broke a record last year in terms of methane increase in the atmosphere. And if you look at the end of the chart, it certainly looks like that level of increase is rapidly increasing. We are releasing more methane even faster. Now look at these graphics yet again. Here's the location of the locked up methane in the permafrost. Here is where we have greatly increased Arctic temperatures. And look at all the methane hydrate that's locked up in the far northern oceans. You put them on top of each other, you can see why we could potentially see massive increases in the level of methane release in coming years. But not just that, don't forget, it doesn't really matter in the oceans. All that matters is the mid-column of the oceans. That's where the temperature increase happens, which could happen pretty much anywhere in the global oceans if we keep increasing the temperature of the atmosphere and the oceans. Could we potentially be on the edge of a massive and unprecedented release of methane that could cause global temperatures to spiral upward at a much faster pace than they already have? Right? Like I said, don't forget, methane is at least 25 times as potent a greenhouse gas, maybe as much as 80 times as potent. I'm not sure if you know about this, but did you know that there was actually a period of time before the dinosaurs where planet Earth was actually filled with vibrant life, both plant and animal, both in the oceans and on land? And what happened is there's actually pretty compelling evidence of a climate-induced massive release of carbon dioxide followed by a massive release of methane leading to this devastating mass extinction. It was called the Permian Extinction, but it's also known as a period called the Great Dying. And in that period, 99% of all plants and animals died, and more than 95% of the ocean species perished. This was right before the rise of the dinosaurs. And, as we said, it was probably volcanic in origin. There's great confidence coming around that it was related to perhaps the biggest volcanic eruption in deep history, way bigger than even the supervolcanoes you've heard about. It's one that created what is now known as the Siberian Traps. And it's a kind of eruption called a large igneous province, I believe, where a giant crack opens up in the earth and just unbelievable amounts of lava come up on the surface for tens of thousands, even hundreds of thousands of years. Think like Kilauea in Hawaii, 20,000 times bigger. I mean, it's just massive. And what happened was, as part of this mass extinction, the trapped magma underground, sort of the volcano capped itself. The magma was still trying to push up and went sort of sideways through the ground, and it went into carbon-rich rock and dark, deep underground layers of likely fossil fuels, coal, oil, natural gas. And it started building up huge amounts of carbon dioxide. And then it finally got to the edge of the lava cap, and it broke through the surface, causing CO2 to rise massively. But then what happened, which is even more diabolical, that caused temperatures to raise a few degrees globally, which then led to a massive increase in methane. Massive release of CO2 caused by burning of fossil fuels, leading to a massive release of methane, raising temperatures even more. And it was that second level of temperature increase that threw off all of the ecosystems, and the plants and animals that were there just could not handle that level of quick climate change. Doesn't sound familiar at all. Now, I'm not saying we're definitely heading to a mass extinction event. I don't think we can completely dismiss that possibility, especially if we keep on this same path for several more centuries. I'll tell you what I'm much more worried about. It's a midterm food productivity crisis coupled with a rapid amount of sea level rise. And what that could do is potentially cause massive famine and displacement of people that could literally affect billions of human beings. And you got to think about this. In previous videos, I mentioned the fact that there was some research that says somewhere 2, 3, 4 degrees of temperature rise, that's when we're going to start to see massive crop losses. And we already know that there's a chance that sea levels could rise in a matter of feet by the turn of the next century if we don't curb our emissions of fossil fuels. This all seems relatively reasonable for it to potentially happen sometime in the next few decades. And if we have a massive release of methane before then, it might even be here sooner than we think. Now, I'm going to put a couple links to videos on this Permian extinction, because I think this is a period of time, an analog in our deep history, that everyone should be aware of facing what we're facing right now with the climate crisis. You have to understand that what we're doing is we're playing with our global thermostat, and we really don't know when we might trigger a cascade that delivers some form of catastrophic negative climate spiral. It certainly does seem to me that it's a bit foolish to be doing this massive experiment with our atmosphere and our biosphere, the only ones that we have, with no guarantees what it might lead to. Do some research on this, find out the facts for yourself, make up your own mind. But if you agree with me that it's not just CO2, but it's the rapid increase of all of these greenhouse gases that's a big problem, and it's getting much worse right now, it's time to be informed, it's time to educate, it's time to advocate, and it's time to make the necessary personal changes to help us have a chance. If you want to get more info, go out to my website, climatehottopic.info. You'll see on that website that I've also created a Facebook group. There's a link to the Facebook group, my Twitter feed that I've changed over to this topic, as well as an ability to, connect with me on LinkedIn. I'll put the link to all of these in the comments below also, so you can get to those. But remember, you can get to them from the website. On the Facebook group, there is a rough draft of part 1 of my new book, 8 Billion Little Volcanoes. And you can actually go there and download the book and read the first half of the first draft. I'm still working on the second half, but the first half talks about all of this evidence and a lot of this information. And so use this as a starting point for you to start your own research, your own study, your own advocacy in this area. Please read it, share it, and then start doing something positive with this information starting today. And if you like these new videos, please like the channel, please subscribe. We all need to be students, advocates, and activists on this hot topic for now and the future. It's the only planet we have. Thanks for your help and support. Watch for the next episode soon.